What's up, guys? This is the next section in Chapter 5 here called Completing the Square. You'll want to pause and copy this down. Don't freak out on me because it's some weird-looking algebra, but it's really not too bad. It says, in general, you could change the expression x squared plus bx into a perfect square trinomial by adding b over 2 squared to x squared plus bx. What you're adding to this, what you're missing, is that plus c part. Right? So remember, it's ax squared plus bx plus c. So we're adding a plus c. This process is called completing the square. Process is the same whether b is positive or negative. So let's go ahead and jump in. But first, what do we want? Better memory. When do we want it? Want what? All right. So finding c to complete the square. What is the value of c such that x squared minus 16 plus c is a perfect square trinomial? So this is just using that b over 2 squared. Well, b in this case is negative 16. So I'm going to have negative 16 over 2 squared, which is equal to, let's see, that would be negative 8 squared, which equals 64. So to find the value that you would use would just be 64. So c would equal 64 in this instance. This is all we're doing, is just practicing getting to that value. We'll work with it in just a second. All right, so pretty straightforward on that. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so 100. Hopefully you found that. So well, I should write it like this. C equals 100. There you go. Let's keep going. All right, so solving. So how do we use this? Well, the first thing that I have to do is get this so that it is x squared plus bx. In other words, I need to get this on the other side. So first thing will be to subtract 16 from both sides. This is a method for solving a quadratic, by the way. I don't know if I made that clear. But you can complete the square to solve a quadratic. Now, I'm going to ignore this just for a second. I'm going to focus on this right here. This is where I'm going to be using that b over 2 squared. So here, b over 2 squared, you should be able to do this with mental math, frankly. It should be really easy for you. What's half of this? And then square it. Well, half of 14 is 7, and the square of that is 49, or half of negative 14 is negative 7. Negative 7 squared is still 49. So I'm going to add that value to complete my square. So right here, I'm going to add 49. Now my property of equality says that if I add 49 on this side, I have to also add 49 on this side. Now this, going back to our special cases, is a perfect square. All right, in other words, this is a square, this is a square, this happens to be 2ab in the middle, which is what I'm looking for. So here, I could write this out and say that's x minus 7 squared equals the difference of these two, which is 33. And in order to find this, I would do the square root of both of these different things. All right, so we'd square this, square that, I get x minus 7. Here's the part that you got to be really, really careful with. X, or 30, the square root of 33 is going to be a plus minus 5.74. What that means is a positive and one's a negative. So I need to solve for two different things here. I'm going to have x minus 7 equals positive 5.74. And I'll go ahead and solve for that. So add 7 to both sides. I get x equals 12.74. And then I also have when x is equal to negative 5.74. Still adding 7 to both sides. But I end up getting x is equal to 1.26. All right, so my answers would be x equals 12.74 or x equals 1.26. So I'm going to have two answers on that by completing the square. My suggestion is you go back through and just double check this, because if you were writing this as I was talking, you may not have paid attention. I would go through and check your notes again, maybe even go back and listen again. But the big thing here is I'm going to have two answers, and I'm completing the square. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here is what I got. Went through, got 2.29, so then I'm just subtracting 4.5 from both of those. So go back through my work, try to follow what I did, find your mistakes. All right, so the equation y equals x minus h squared plus k represents a parabola with a vertex hk. You can use the method of completing the square to find the vertex of the quadratic functions in the form of x squared plus bx plus c. So it says find the vertex of x squared plus 6x plus 8 by completing the square. So we're going to do what we were doing before. So the first thing is I'm going to subtract 8 because I got to get it in that x squared plus bx form. So subtract 8 from both sides, and I get y minus 8 equals x squared plus 6x. And then from there, I need to find half of this and then square it. So that's going to be 9, because 3 squared is 9. And I'm going to add that to both sides. And then from there, I'm going to, first of all, add these two things. So I get y plus 1. And then over here, I'm going to go ahead and write that out. So that's x plus 3 squared. That's my special case. And then my next step is to subtract 1 from both sides so that I get it into this formula right here. So when I subtract 1 from both sides, notice what it looks like. I get x, this is plus 3 squared minus 1. So my vertex is going to be the point that's given by hk. This is negative h. So h is going to be negative 3. And then this is plus k, so my k is going to be negative 1. The vertex of this equation is that. This can be a super helpful thing for finding the line of symmetry, or the axis of symmetry, as well as just finding the vertex. If you're going to be graphing, you could start by this to find where you need to plot that first point. Okay, so negative 3, negative 1 is the vertex by using the process of eliminating or completing the square. Double check your notes on this, because again, this is kind of complicated looking stuff, and I want to make sure you have good stuff written down. Here's one for you to try. Go on and pause. The answer will be up in 3, 2, 1. All right, here's what I got. So negative 2, 6. Double check yours. Hopefully you got the same thing. If not, you need to go back and try to find where you possibly made a mistake. Let's keep moving. All right, dreaded word problem. All right, completing a square when a doesn't equal 1. It says you are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border. Total area of the garden and the border is 100 feet. What is the side length x of each square plot? This is kind of a big, ugly problem, so make sure that you have plenty of room on your paper. First thing is I got to write out the formula. So the area is going to be 3x plus 2. So I have 1, 2, 3 x's plus the 2 times my length, which is going to be x plus 2. And that area equals 100. All right, so I need to FOIL that sucker, and I end up getting 3x squared plus 8x plus 4 equals 100. All right, now my next step is I need to get this thing over here, so I get it in that form that we're supposed to work with. So 3x squared plus 8x, I'm subtracting 4 from both sides, equals 96. Now the problem I'm running into is you'll see here where a doesn't equal 1. In order to complete the square, a must equal 1, which means I need to divide everything by 3. So I'm going to divide whoops, there needs to be an x there. Divide all of these values by 3, and I end up getting x squared plus 8/3 x equals 32. Now from here, I'm going to complete my square. Now don't freak out about this. This divided by 2 is just 4/3. And then I square 4/3, which is 16/9. If you remember your exponent rules. Really not too difficult there. So I'm going to add 16/9 to both sides. So I get x squared plus 8/3 x plus 16/9 equals 32 plus 16/9. And I'm going to have to come up here so that I have room. And once I do that, I square this first part. I get x plus 4/3 is squared equals, this is kind of an ugly number, 304, because I want to leave it as an improper fraction, 304 over 9. Now from here I find the square root of both of these, so I get x plus 4/3 is equal to plus minus approximately 5.81. All right, so 5.81. From here I'm going to add 4/3 to positive 5.81, or x plus 4/3 equals negative 5.81. So subtract 4/3 from here, and I get x equals about 4.48. And then over here, if I subtract it from both sides, I get x equals about negative 7.14. Now the problem here is I'm looking for the side length of x. Well, this is a negative number, so it can't be that side length, which means it must be this. So the side length of the boxes must be 0.48 feet, approximately. Almost 4.5 feet are the side lengths for that total area. That is really long and complicated. A couple big things from this is that, first of all, you cannot have anything other than 1 in the a value. So you got to get that a value alone. If we have problems like this in class, just make sure you're seeking help if you get stuck on it. Again, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9 steps, and I'm skipping steps here. So there's a lot more than that. So are kind of combining some steps. So be careful with this problem. This is a tough one. All right, so again, double check all your notes. Make sure you have all this down. I believe that's it for today. It is, so hopefully you took good notes. I will see you all in class.